Hi, good afternoon, everyone. Meini Su. I'm a senior lecturer in structural engineering. I'm so happy to get this opportunity really to share what we've done in terms of decarbonization of concrete and construction industry. So actually, I'm one of the group members in a big group working on construction material and structural engineering. In the recent years, my research group has spent quite a lot of efforts on the sustainability and circular economy in construction industry. As we all know, the construction industry is one of the biggest sectors in the global economy. And the UK's construction market size has reached more than 500 billion in 2023, and expecting to keep more than 2% increase during 2025 to 2028. And over 19 million tons of concrete was consumed in a typical year for an amazing range of uses, basically, which is equivalent to about 4.5 billion pounds. So as a major consumer, the building sector uses around 55% of materials and 3% of primary energy, and at the same time generates about 62% of waste annually in the UK. So I think the biggest challenge this industry is facing at the moment include, one, the high carbon emission. Unfortunately, about 8% of the world's carbon dioxide was coming from the cement and concrete industry. This is because when we produce about 1 cubic meter of concrete, we actually need to emit about 400 kilograms of carbon dioxide. And second, the widespread use of concrete is actually exhausting the diminishing natural aggregates like coarse aggregates, fine aggregates. And also the construction accounts for more than 40% of landfill waste. So as an essential construction material, we think decarbonizing concrete is one of the key opportunities to reach net zero and help to reduce the carbon emission from the built environment. We can see there's a clear move towards a more carbon-friendly approach in this sector, and with the development of low carbon cement and concrete. I think the UK's green building sector has the value of the green building sector is about £6 billion. That's the data I read recently. And this is mainly driven by the legislative shifts towards reducing carbon emission from the built environment, as evidenced in many policies like UK industry decarbonization strategy, for example. I think graphene, as a magical 2D material, I think it has the potential to solve some of the challenges. So graphene, as we all know, it has superior properties. For example, ultra-large specific surface, super high mechanical properties, extraordinary electrical, thermal conductivities, which all of these properties will lead to various benefits to concrete. For example, can help concrete to generate more compact microstructures for better resistivity and durability, can significantly increase the strength of concrete, or bring in much better electrical or thermal conductivities for multifunctional smart concrete. And at the same time, graphene is also a very efficient nanomaterial. So even adding a tiny amount of graphene into the bulky materials such as concrete, it will make a significant change to the properties of a concrete. So the graphene nanoplatters, when we add them to the cement paste, they will act as the nucleation seeding to accelerate hydration, to allow the formation of more hydration products, and to densify the microstructures of a cementitious material, and then finally results in improved strength for concrete. So here at Manchester, we're not only interested in the final performance, but more importantly, we have the most state-of-the-art technologies to support the research at different scales. For example, at the microstructure level, we have all of these analytical technologies to qualitatively and quantitatively understand the working mechanism of graphene in cement paste. So for example, we will be interested in how the graphene interact with different components in cement paste, how they affect the hydration process at different curing conditions, and we try to quantify the effects of graphene at different phases as well. For example, in addition to the conventional SEM observation to get the 2D image of graphene in the hardened cement. And we also try to develop a more systematic approach to quantify the distribution of graphene. So we use XC scanning with thousands of the XCT images. We were able to generate some 3D model of and to get the graphene distribution in the hardened cement. And with that, we can comprehensively to establish the relationship between the graphene agglomeration and the strength development. Of course, we also have some conventional material characterization facilities in the engineering campus to measure those fundamental properties of a concrete, like setting time, workability, strength, and surface resistivity, as well as some large-scale structure testing facilities to get the loading performance of the structure members like reinforced concrete beams, columns, slabs, walls, and whatever under different environment conditions or subjecting to different loading conditions. We think these tests are very important and necessary because they can validate the hypothesis at the structure level. They can prove the concept, de-risk the solution of a low-carbon concrete, and more importantly, give more confidence to the industry partners for wider application. So with all of these fantastic facilities at Manchester, my research group has carried out a variety of research activities surrounding the graphene concrete. So for example, we've developed some graphene-enhanced cement products. We've used graphene to enhance the performance of a geopolymer concrete. And we've worked with the HSE, Health and Safety Executive, to look at the health and safety concerns of handling graphene, or the occupational safeties of the built environment involving graphene, life cycle assessment and economic viability of graphene products, and so on. But with all of them, I would like to just take the graphene green concrete as an example to demonstrate how we work closely with the industry partners to realize knowledge transfer and to commercialize the research output for industry application. So the idea of graphene green concrete was initially started from a PhD project, and it was recognized by the Ali Harari Graphene Enterprise Award. I know we have a ceremony later. Congratulations to all of the new winners, and we really appreciate opportunities and support, financial support, and also the resources that we got from the Ali Harari Award. And with those start funding, we managed to set up a company called Graphene Green Concrete Company. Then we secured further fundings from the Innovate UK to further optimize the product and also carry out some more detailed market analysis as well. And then since last year, we got a chance to work with more industry partners to complete 2 on-site casting for demonstration. So what is graphene green concrete? It is kind of concrete that uses a tiny amount of graphene and use 100% recycled aggregates to replace the natural aggregates, but still achieving comparable performance to the conventional concrete using natural aggregates, at the same time without disturbing the existing manufacturing process. And the technical uniqueness of the graphene green concrete include we use graphene to enhance the performance of cementitious material. We try to use less cement in the concrete mixture, and we use 100% the concrete waste as the coarse aggregate in the mixture. Our vision is to develop a practical and cost-effective solution to upvalue the recycled aggregates. So we hope in the future, if a building has to be demolished, we can build a new structure in the same place using the same materials, achieving zero landfill waste. So in order to demonstrating that, we have done quite a lot of comprehensive experimental program at the laboratory to investigate those fundamental properties of the graphene green concrete first, and also compare them against the natural aggregate concrete. All of the results tells us that graphene green concrete actually can achieve comparable properties to natural aggregates, and also those fundamental properties like compressive strength, tensile strength, workability, surface resistivity, and failure modes. They can all satisfy those the industry's requirements. And in some of the cases, those strengths that obtained from graphene green concrete are even less scattered. So those consistent results can lead to higher characteristic strengths for structure design purpose. And when we look at the pictures of the testing specimen, we can see that there's perfect bonding basically between the cement paste and the aggregates. There's almost no difference at the interfacial transition zone between these two mixtures. And then in practical application, as I said earlier, we try to minimize the disturbance to the existing procedure. So when we do the practical application with the industry partner, we try to use the raw materials and then mixing formula provided by them. What we need to do is just do a little bit of validation at the lab before we do the large scale casting. So in terms of the recycled aggregates, we are basically open to all sources of recycled aggregates, because at the laboratory level, we chose the poorest quality of recycled aggregates to prove the concept, so that now we don't really have much constraint on the selection of recycled aggregates. This is a diagram showing some of the results from a demonstration, one of the demonstration projects. As I said earlier, the raw materials and the mixing formulas were all provided by the industry partners, which have been used in their existing project. Without a lot of effort, you see that graphene green concrete can easily achieve 15% higher strength, and that will enables the use of less cement without reducing the strength compared to their the concrete that they have using in the current project. And then the other key challenge that we are facing for application for using graphene concrete is the logistics concerns, how we disperse the graphene into a big volume of concrete. So in order to tackle this challenge we always provide the graphene dispersed solution to our client. So what we have done is we mix the graphene with a small amount of water or superplasticizer or the surfactants by using ultrasonic cates or ultrasonic bars or other high shear mixers, whatever. So we get these bottles of graphene solutions ready, and we transport them to the construction site. What the contractors need to do is just add this bottle of water to the water, and then this bottle of solution to the water, just like other additives. So there's no additional skills needed really for the contractor, or no need to change any existing setup. And then earlier this year, we got the chance to work in one of the United Utilities project as a winner in their Innovation Lab program. We got a chance to do to cut some demonstrators in their Innovation Center. We tried 4 different mixtures in this project. One is the reference mixture, and then we tried 3 different graphene green concrete mixtures with different graphene sources and different cement amount. And we also use some light reinforcement arrangement to meet the typical concrete asset to check the compaction around the rebars. After the casting, we did some visual inspection to the conditions of like bleeding, curing, and joint shrinkage. We also, after 7 days, 28 days, 14 days, and 28 days, we did some coring to get the cylinder samples from those on-site large-scale specimens. So these slides shows the results that we've got from some of the coring specimens and also casting specimens. Well, in general, the specimens that were cured in a lab condition with controlled moisture and controlled temperature, they got higher strength than the specimens that were cured in the open air condition. Well, that is what we expected because the whole activity was carried out in the winter. And then what we happy to see is that compared to the natural aggregate concrete, the graphene green concrete were actually enjoyed 50% higher tensile strength, even though in this case the improvement on compressive strength is less significant. And we also did the cost comparison for those mixtures because we know price and profits is very sensitive in the concrete industry. So any change to the price can make a significant change to the adoption of the new product. Through the cost comparison analysis, and then we found that the graphene green concrete has a competitive price to the conventional commercial concrete. Even though we know that price for graphene is still relatively high, but in this mixture we use the tiny amount of graphene. Also because we use recycled aggregates, the price for recycled aggregates is lower than the natural aggregates, so we managed to keep the price neutral. And in addition, if we consider the landfill tax saved for graphene green concrete, the price for graphene green concrete can be even lower. And then for the environmental perspective, we've done the analysis for the embodied carbon. When we dig out the data, the raw data for the materials, very surprisingly, we found that, wow, the embodied carbon for the recycled aggregates is even higher than the virgin aggregates. The explanation from the literature was saying that this is associating with the distance, the transportation distance between the demolished site and the recycling plants. Well, agree or not, but the data there will actually discourage the reuse of the recycled aggregates. So my research group have exploring various solutions, and we found that, well, there are two promising solutions. One is to to optimize the transportation distance, basically, and improve the co-location strategy. And second is to outbalance the embodied carbon by the carbon dioxide uptake in the carbonation treatment for recycled aggregates. So, as an ongoing project, we are now exploring to introduce carbonation to the recycled aggregates. And theoretically, those carbon dioxides from the cement manufacturing or concrete manufacturing or any other factories could be the sources for carbonation. And based on the sources, the UK concrete and cement industry roadmap, it seems that the carbonation technology and the carbon capture technology together, they can save 73% carbon dioxide. That's amazing. During the carbonation process of reactions, what happened is the carbon dioxide will take the reaction with the calcium hydrate and calcium silicate hydrate to form the calcium carbonate and silica gel. And these two materials will fill the pores of the old mortar attached to the recycled aggregates. But this old mortar layer, normally they are quite porous. And then after carbonation, the solid volume in this old mortar layer can be increased by about 12%, based on the equation 1, and 23% according to equation 2. Therefore, carbonation basically can increase the density, decrease the water absorption of recycled aggregates, and resulting in increased the flowability and also decrease the drying shrinkage, but resulting in better strength for the recycled aggregate concrete finally. The laboratory tests are already validating, kind of investigating and validating these two potential methods for carbonation technology. One is under the dry condition, the other one is under wet condition. And the benefits of carbonation on recycled aggregates has been validating as well. From the test, we found that about 64 kilograms of carbon dioxide can be permanently sequestrating by 1 ton of recycled aggregates. And the water absorption of the recycled aggregates can be reduced by 16%. The strength of the recycled aggregate concrete can be increased by 42%. And then through the conversations that we had with our industry partners, we have identified a clear supply chain for the graphene green concrete with carbonating recycled aggregates. Based on the data we've collecting in terms of cost, location, efficiency, availability, and so on, about the raw materials and energies, we found it feasible and promising path for commercialization. Looking to the future, we do hope to de-risk the use of low carbon concrete at real access. And in order to achieve that, we do need to work closely with the key stakeholders in the supply chain to get accreditation for the low carbon concrete. I think accreditation is, if not the only path, then the most important step in the path to give the market confidence for wide application of a low carbon concrete, and finally leading to decarbonization of the construction industry. Here are the representative public research articles published by my research group. We have systematically investigating many opportunities of using the nanomaterials to improve the various sustainable biosystemsystems. And we would like to acknowledge all of the research fundings that we've received to support the relevant research. And we're very happy that the research work we've done and the collaboration with the industry partners have attracting a lot of interest from the public in the field. With that, I would like to wrap up my presentation. Thank you for your attention. Any questions are welcome. Thank you, Jim.
Again, a chance for any questions from Meini. Any questions in the audience? Ivan, I'm sure, has got one. Or Mark or Lisa.
Hi.
Thanks very much. Good talk. Is there the recycled aggregates? Is that just concrete recycling, or have you done a mixture kind of other aggregates such as bricks, cement, mortars? Have you baselined against any other mixed aggregates?
Yeah, that's a very good question, because the recycled aggregates have different categories. Most of the research we're doing is with the recycled concrete aggregates, but we've also tried with some other categories as well, with the mixture with other type of aggregates. The results all prove that we can use them, but we just need to test a little bit on the mixture. We gain similar strengths, but we need to do a little bit of testing on the mixing formula, yeah.
I think there's a real theme emerging, and you see this tomorrow as well, turning waste into value. So again, a big discussion around supply chain, critical minerals, so the whole transport of cement. Quite interesting for me, just looking at the metrics, how you measure something can actually motivate or demotivate you from doing.
Yeah.
But if you take your local material from local sources,
exactly,
then your cost of transportation is very low. So
exactly,
again, maybe there's some learning in that as well. Any other questions that people would like to raise?
Hi.
On the microphone.
Could you please explain about XCT scanning?
Yes, do you need it?
Thank you. Could you please explain about the XCT scanning, please?
Yeah, so the XCT, the part, the contents about the XCT scanning is part of a PhD project by my PhD student. So what he has done is he's taken thousands of XD images basically, and then he used Poisson program to review a 3D images of that concrete, not concrete, but mortar, the mortar samples. And then with that, he needs to use some kind of numbers category to just identify different phases like cement paste, but also pores and graphenes as well. And by using some of the technology, it's quite long, a long journey, I have to say, with several advanced technologies. But in the end, he just needs to isolate the graphene out of all of the other phases so that we can see the size of graphene, we can see the exact location of graphene. And because we all know that graphene will re-agglomerate during the hydration process. So that is very important because even though the graphene can be well dispersed in the water and a solution, but no one can ensure graphene will actually quite uniformly distributed in the hardened cement as well. So this is we think it's very useful because for us to understanding the distribution of graphene during the hydration process. Yeah.
Is it like electron spectroscopy, is it?
Pardon?
Is it like electron spectroscopy?
No, it's different. But I can share with we are preparing a paper. I can definitely share with more information, detailed information.
Thank you very much.
With you.
Okay, any final questions? Ivan, there you go.
Thanks, May. I guess my question is less about costs, which are the key thing that people keep saying about graphene and concrete. In the case studies you've done so far, has there been any discussion about value? Because the value of concrete is not just in terms of the pour, but the properties you get, but also the fact that it cures quicker, the potential removal of rebar. Has there been any calculation of the value side rather than the cost equation?
Thank you. That's a very good question. Yes, we did realize when we add graphene to the concrete, we were easily to get more improvement at the early day strengths. So that's something we should make good use of in the real application in the construction projects. But those cost analysis haven't including that part. But yeah, that's a very good point. If we're going to do a more detailed analysis of the cost benefits of graphene concrete, that's something we should definitely consider.
Okay, so one more.
Yeah.
How stable is the graphene solution? What's the shelf life of it?
Yeah, that's another very good question because we need to make sure that the graphene solution is stable enough before we transport it to the construction site. So what we've tried in this project is about 7 days to 14 days. They are quite stable. Yeah, I think we haven't tried longer term, but I know there are some companies or researchers are going to extend that shelf time to even 6 months. And so that's promising. I mean, we can definitely produce a more stable for longer term solution. Yeah.
Okay, and I think that's a good theme that'll lead into tomorrow. We talked about being academic-fed but industry-led. So it's no good doing the academic work if it's not suitable for application with industry. And I think concrete is probably one of the most applicable areas where if you don't do things in the thousands of ton type scale up, then industry won't take it seriously. So I think that's probably a key theme. Hopefully we'll pick up for those people who are here tomorrow as well, that the commercialization needs to be viable in industry if it's going to be adopted and taken up. And I think there's some good lessons learned there on the concrete and the construction, because they do things in a very particular way and they don't want to reskill or re-equip or change processes.
Yeah.
Okay, thank you again, Meini.
Thanks, Jeff.
Really good. Thank you
Okay,
for the presentation.
Thank you.